Let's take a look at this problem called merge to sorted list. So in this problem, we are given two lists, list 1 and list 2. We are supposed to merge them together, and these two lists are already sorted, and the merged list should also be sorted. So as you can see in this example, 1 to 4, it's a sorted list, it's list 1. 1 3 4, it's another sorted list, it's list 2. And when we merge them together, we have a sorted list. If the elements are equal, we are going to consider them as equal and the order can be anything. To solve this problem, we need an understanding of how linked lists work. There is another concept I would use, which is of dummy node, and I can explain that in a while. So, what would be the general algorithm for this problem? What I would like to do over here is the one thing I know for sure, I have a pointer to this node. In the question, it's given list 1. This list 1 is actually the heads of the pointer. You can see over here, sorry, the heads of the linked list. It is a head on the linked list, so it's pointing to list 1. Over here, it's list 2. Now I need another pointer which I would like to call current. This current would point at the element which is the smaller of the two in list 1 and list 2. This current would point at the smaller of the two, and you would very quickly realize why we are doing something like this. Also, I said I'm using the concept of a dummy variable, a dummy node. So in linked list problems, we don't want to deal with edge cases. And to refrain from dealing with those edge cases, we use a dummy node. So I would create a kind of dummy node over here, and current is currently pointing to this dummy node. Now let's take a look at the algorithm. For the purpose of simplification, I want to call them I and j. Now, which one is smaller in between I and j? They are both equal. So let's just pick one of those. Let's pick I. So when I pick I, what I'm going to do is I would say currents next, current dot next. I would point this to the element that is smaller. Right now, it's I. So I would point its next to over here at 1. And I would change the value of current to this place, which is I right now. And I would modify the value of I and I would move it to over here. And I would keep j as it is. So now it will look like this. We have a current pointing at 1. We have a dummy. We have I shifted to the next position over here. So now I is here, j is here. Which one is the smaller one? We know 1 is the smaller one, j is small. So this time, again, the same algorithm. We would point current to this place. So currents dot next would point over here. This got broken. Current dot next, we are pointing over here. And current moves to this. This is the new current. And I moves a position forward. This is how it would look like. Let's go to the next step. We have I at 2. We have j at 3. Which one is smaller? We know 2 is smaller. So current dot next pointing to 2. You can see this link got broken. And current is pointing at 2 again. Okay. Current pointing at 2. This is now gone. Current is pointing at 2. Since we are done with pointing, let's move I forward by 1. So now I is pointing to 4. So 4 and 3 are the numbers in question. Which one is smaller? We know 3 is smaller, right? So current dot next, which would be pointing to 3. And current would be gone from here and it would start pointing to this place. Now, since we are pointing to this element, we need to move J. Now, let's move J to this place. We have elements in question, this place and this place. We can take any one of those. Let's take the first element from the list 1. So, current is pointing at 3, current dot next pointing at 4. This becomes the new current and looks like we are done. So we are at 4. I is exhausted. You cannot go forward. Usually we were going forward by 1, right? This time we can't go forward. We have a J left. This is an element left. In the end, we would just see that, you know what, which of these linked list is not traversed. So we can say the list 2 is not traversed. At the end, we would add a check. The linked list which is not empty, we would point the current dot next to that location, and we don't need to move current and all because there are no new elements. And even if we had something like this, even if we had these elements, they are larger than the list we have over here, so we don't have to deal with current after that. I know this is a messy algorithm. When you look at the code, you would understand things better. What you need to understand is basic of linked list over here, and we have this concept of using current to traverse, and we are manipulating the existing linked list. And this is a concept which is used many times in linked list problems, and it's very important to understand how it works. And also the dummy variable, which makes our life very easy. So, what would be the solution in this question? Like, what would be the solution? Let's look at the solution. We need to return the pointer to the head of the final linked list, right? And this place now current has moved to somewhere here. This cannot give us an answer. What do we have over here? We have the dummy. Dummy is somewhere over here. So we can say this node is actually dummy.next. This is the first node because all these values are destroyed. I is moved, J is moved, current is somewhere over here. The node which can give us a solution, which can give a pointer to us is dummy.next. That's how we are going over here. Next step, let's dig deep into the code. Okay, so what we are given, we have a solution class. We don't have to worry about that. We have the function which we need to implement merge to list. We are given the head of a list, which is list 1, and it's of type list node. We have a list 2 and it's of type list node, and list node is defined over here. It's a very, very basic linked list. And we need to return a head of the merged linked list. First of all, let's create our dummy node. So I'm going to create it something like this. I am instantiating a empty dummy node. I want a current pointer which would point to this dummy node. Now let's traverse through list 1 and list 2 together. So while we can say list 1 and list 2, while these two lists are available, we need to perform some check. If list 1 dot value, its value If it is less than or equal to list2 dot value, okay, we are adding a less than because we want to find out the smaller element, and we are adding an equal because they can be equal, and if they are equal, I want to prefer list 1. There is no hard and fast rule. You can prefer list 2. So if we get a list 1 as a candidate of this, as a positive candidate of this if condition, then what I want to do is I want, what did we do? Let's point the current dot next to list 1. This is the head 1, right? This is the head of list 1. Pointing the current, let me draw a diagram for a better understanding over here. We have something like this. We have a list like this. We have a list like this. We have a node like this, sorry. We have current over here pointing to some dummy thing. Now we want to point at the first element. So current dot next. So also I don't want to increment I first, because if I increment I first, I lose the identity of this. In a singly linked list, you cannot go back. So I lose the location of this. So I don't want to increment the I first. I want to point first. So current dot next, I do it. And then I change the value of current so I can store its location. And then I can modify in I anywhere I want. So that's how I would like to do it. So here we are, current dot next, pointing at list 1. Current needs to be modified. It's equal to list 1. Also, we are going, we are doing I equals to I plus 1. So in this case, it would be list 1 dot next. That's how you do it. Since it's not an array, it's a linked list. We need to do the node equals to node dot next. Very standard linked list. Else current in, so what is the else condition? If this is not true, which means the list 2 element is smaller. So current dot next, very similar, just performing that operation with list 2. Current equals to list 2 and list 2 equals to list 2 dot next. Exactly the same code with list 2. Now we are done with traversing these two. We don't have to do anything with this while loop. But there is a possibility that one of the linked list is not empty. There is a very high chance that one of the linked list is not empty. Because okay, over here we are saying while list 1 and list 2. So list 1 is exhausted, list 2 is not exhausted. In this, which would always happen, I guess. So in this case, we are going to check if list 1, if it is not exhausted, if the list 1 is not exhausted, okay, what would be the scenario? There are elements at the list 1. So I need to, list 2 is gone. So no need to worry about list 2. So current dot next equals to wherever the list 1 head is, this head, wherever it is right now. Else if I'm going to say if list 2 is available, current dot next equals to list 2. We are done. And in the end, we can return dummy dot next because this is the only value which can point to the beginning. Dummy dot next. Let's try to run it. So we are beating 100% of the people.